Welcome back to Comp 1405. In this chapter, we'll delve into another essential component of the Introductory Programming Toolkit, specifically functions. Functions are a way of organizing our programs to make our code simpler, more efficient, maintainable, and reusable. In fact, functions are such an essential part of programming that we've used several without even discussing them. Some of the functions we've seen before include print and input, the type conversion functions like int and string, and we also imported some functions from the Python modules like random. In general, these operations are each known as function calls. They're each a request to execute some code instructions that someone else wrote. So let's open Python to briefly recap the syntax of function calls. In VS Code, we'll open up an interactive Python interpreter. Now we've been using functions already, so for example we've seen things like print hello, or x equals the string of 3. These are function calls. At their most basic, the syntax of a function call is just the name of the function followed by a pair of empty parentheses. For example, we could say print with 2 empty parentheses, and that just prints out a blank line. Note the parentheses are necessary to make the function work. If we just say the word print, Python responds by saying, that word refers to this built-in function that I know about, but it doesn't actually use that function. If we include the parentheses, that tells Python to actually execute that function. This is the function call. Now, for more versatile functions, we can also include input arguments. For example, we can say print hello, which we've seen before, or we could even say print hello goodbye, and include 2 arguments. Note if we have multiple arguments, we have to separate them with commas. The last part of a function call syntax, which ironically is written first, is to store the result in a variable. So we could say, for example, user word equals input say something. We're prompted to say something, and I'll say hello, and that gets stored in the variable user word. We could also say x equals the string of 3.14. And now x has the string of 3.14. This calls the function, and it stores the result in the variable that we've assigned it to. Note the function itself has the value. So if I could just say int of 3, that has the value 3. But unless we store that value in a variable, we can't use it in the subsequent steps of our programs. So this is the basic syntax of function calls in Python. Note that they all generally follow the input, process, output structure of whole programs as we discussed in Chapter 1. So you can think of these built-in functions as programs that someone else wrote, which we can borrow for our own purposes. One exception to this design is the print function, because it doesn't actually produce any value. For example, I can say x equals print hello, and it prints hello as we'd expect, but if I ask what's the value of x, there's no value. This happens because printing to the terminal is what's known as a side effect in programming. A side effect is when a function does something other than compute its inputs to its outputs, something that has an observable effect outside of the function itself. Examples of this are displaying to the screen, like in the print function, modifying a file, or even sending network requests. So the print function does this side effect, and that's all it needs to do, so we say it does not return a value. And now that we've reviewed what we know about the built-in functions, today we're going to take a look at writing our own functions. A function is a block of code that we set aside as a single entity and give a name. So we say, this part of our code solves problem X, so bundle it together, stick a name on it so that we can refer to it later. Then all we need to do is call that name, and the code will run. So functions are also known as subroutines from back when programs were called routines, and this highlights the fact that functions are like mini sub-programs. Another name you'll hear is procedures. So the term function itself is more precisely used to denote the math-like functions which return a value. So for example, f of x is equal to 3x plus 2, or y equals mx plus b. These are basic functions in the math context, so a function in programming is technically a procedure that fits this definition, but we'll use the two terms interchangeably throughout this course. You may also hear the term method used to refer to a function. Methods are another specific type of function or procedure, one that's associated with objects, which we'll cover at the end of this course and in depth in Comp 1406. When compared to coding without functions, there are a lot of advantages to coding with functions. Some of the main advantages, as we'll see, are abstraction, reuse, modularity, and encapsulation. Abstraction we've already talked about, this idea of having a black box that we don't have to look into in order to be able to use. So abstraction means hiding the unnecessary details behind a simple or simpler interface. This lets us refer to complex operations just using simple names, like do this action without having to specify how the action gets done. For example, all the built-in functions that we used we use without necessarily knowing how they were written, but that didn't affect how we used them. And that's the idea behind abstraction, simplifying unnecessary complexity and dealing with just the necessary details. Having functions in our code also lets us reuse blocks of code. So the idea behind reuse means we're going to write our code once and then use it many times. So if we have some process that we need to use in several different places in our code, rather than typing that same code in multiple different places when we need it, we can just write it once, give it a name, and then when and wherever we need that code, we'll just call that function. This lends itself to a programming principle known as dry coding, or DRY, where that stands for don't repeat yourself. This reusability means that if we need to fix this process, we only need to do so in one place, where we defined it, rather than everywhere where it gets used. So it simplifies our efforts in maintaining our code as well. Programming with functions also supports the notion of modularity. Modularity means the description of complex things as combinations of simpler independent parts. So they're independent in that each part can be understood at some level without referring to the specifics of any of the other parts. That way we can build large programs out of these easily replaceable parts. So it supports taking large problems and decomposing them down into smaller pieces, solving those smaller pieces as independent functions, and then joining them back together. This is particularly useful in professional settings, where we have very large code bases that need to be divided amongst many teams or individuals. This also helps with code maintainability, because if our functions are very well defined, then replacing one function with another that performs the same operations should have no effect on the rest of the code, so long as it continues to operate in the same way. The internals of that function shouldn't affect things outside of that function. And this also relates to the notion of encapsulation. Encapsulation means bundling data and the process together into a single unit. So functions provide this through what's known as scope, a concept which we'll cover later in this chapter. But in brief, the variables and processes within a function are contained within that function, so we don't have to worry about unexpected interactions with things outside of that function. When things go wrong, then the bugs are somewhat contained, ideally at least. For example, if the user input isn't working in our program, we don't need to debug the random number generator. We can focus our attention to just the functions that aren't behaving as they should. This is what's known as unit testing, where we're ensuring those smaller parts each do their specific task correctly before we combine everything into a whole program. Returning to the notion of program flow, or the flow of control in our programs, we've already seen linear, branching, and repeating flows, as well as the statements which provide them. In terms of program flow, functions are like a detour. When control reaches the function call, it jumps to the function's definition, we run through all the instructions within that function, and when it's done, we jump back to where the function was called. By way of example, consider this flowchart, which describes roughly the process for driving a car. At the high level, on the left here, it's as simple as start the car's engine, drive the car, park the car, turn off the engine. But note the act of driving is an abstraction of a more detailed process, one that involves repeatedly observing and navigating until we reach our destination. If this were an actual program, control would start on the left-hand side at the begin function, but when we encounter the drive function call, the control would jump to the start of that process, which may be written elsewhere in our code and stored elsewhere in memory. We then complete the process in the normal way, following the steps, one after the other until completion, branching and looping as necessary, and when we're done, we jump back to where we left off, and continue on with the main process. In Python, defining a function means basically writing a small program and giving it a name. The syntax for defining a function looks as follows. We start with the keyword def, so letters DEF, which is short for define, and then we specify some function name. This is just like a variable name, and the same rules apply here as well. Following the function name is a pair of parentheses, or round brackets. These are required to be there, but for now we'll just leave them empty. These are a placeholder for including inputs to our functions, which we'll discuss shortly. And then we have the function body. So just like a loop body or an if statement body, this is just a bunch of code that executes, in this case when we call our function. And as in all those other types of code bodies, the colon and indentation are how Python determines where this body starts and ends. Here is a simple function example called myFunction that only contains one single line, in this case a print statement that says this is a function. But note there are two components to a function. There's the function definition, so the def statement, and the function call, where we reference the name of that function. Python will see the definition like a variable assignment. It associates the function name with a value. The value here is the block of code which defines that function. But just like a variable assignment, it doesn't say to do anything with that value. When we define a function, Python says, okay, I'll remember this name means this block of code, but it doesn't do anything with that information immediately. So to run the function, we have to first define it, and then separately call that function. So let's dive in and start creating functions. So back in VS Code, we'll create a new file. Call this one functions.py. And I will say this is a demo script to explain functions. Step 1 is to define a function. So starting with the keyword def, and then the name of our function. Here I'll make a function which draws a little cat, so I'll call my function cat. Remember to include the parentheses and colon, and then we start the body of that function. So the body of this function here is just going to have some print statements that work together to draw a cat. So print So we've defined our function. Let's save our code and try it out. And we'll say Python functions.py. And nothing happens. So note, we've defined a function here, but we haven't called the function yet. So until we've called that function, nothing will run. So step 2 is calling our function. In this case, our function's called cat, so we'll just say cat. Save again, try again, and look at that, we get a cat. Note we have one small word, 3 letters, cat, represents multiple lines of code. Now anywhere in our code where we happen to need the ASCII drawing of a cat, all we need to do is say cat, and we get this cat. Notice we can call it multiple times if we want. I can say cat twice or cat 3 times. Then when we run our code, we get 3 cats even though we only had to write the print statements once. To drive this home, let me just modify our code real quick. I'm going to add some print statements here. I'm going to say before def, after def, before call, and then I'll say print after call. And now running this code, we can see where the function was actually run. So we see our label before def, and then we see after def with nothing in between it, even though that's where the actual print statements exist. After that label, we have the actual function call, and that's where the code shows up. And then we have code after that function call, which also continues to occur. So in terms of program flow, Python will start at the top of our file, it prints a statement, it defines this function, but doesn't do anything with that definition, makes another print statement, and then does something with that definition. So it takes the name cat and associates it with all of these print statements. You can almost think of these print statements. You can almost think of these print statements as being copied and pasted into this line. Note, not cut and pasted because we can call it multiple times. So copied and pasted into those lines. And then our code continues on. So once it's finished all those print statements, we go back to where we made that call and continue on with our main process. To make sure we understand the concept of function call ordering, let's consider this comprehension problem. So I have this code here, a bunch of print statements, a function definition, and some function calls. So this code doesn't define any variables, so we don't need a variable table, but we will still want to keep track of the output of this code. So I'll put an output section here, and underneath we'll put anything that prints from our code. So our code starts in the first line, which says print 1, so a value of 1 gets printed to our terminal. Then it says def foo, that associates the name foo with this function, which in this case says print 2. And then our control continues on with the next line, which says print 3. So now we have another statement that gets printed, value 3. So the next line says call foo. So control will jump to our definition of foo, which just has the body print 2, and we will print 2. And control jumps back to where it was called and continues on with the next line. The next line says print 4, so we'll print a 4. And then it says call foo again, so we'll jump back up to the top of our code, run through the body of foo, which says print 2 again, so we'll get another 2. Control will return back to where it was called, continue on with the next statement, but that was the last statement, so our code is done.